All right. Well, good morning, everyone, or afternoon if you're joining us from the Eastern Hemisphere. My name is Nick Calero, and I'm a senior modeler at Hydronia USA. It's a pleasure to welcome you to today's webinar Simulating, titled Introducing the Most Advanced RiverFlow2D and OilFlow2D Models Yet. This is our version 10 release, and today our presenter is Dr. Reynaldo Garcia. He's Hydronia's President and Director of Model Development and Applications. Dr. Garcia brings over 45 years of experience in hydraulic and pollutant risk assessment and mitigation projects with a strong emphasis on numerical modeling. He holds a civil engineering degree from the Universidad Central de Venezuela, a Master of Applied Science from École Polytechnique de Montréal, and a doctorate from the Universidad Central de Venezuela. He is also a research fellow at the Wessex Institute of Technology in the UK. Over the course of his extensive career, Dr. Garcia has contributed to more than 400 consulting studies across 5 continents and is the principal developer of the RiverFlow2D and OilFlow2D models, which are now used in over 80 countries. So without further ado, please join me in welcoming Dr. Reynaldo Garcia.
Hello, can you hear me?
Loud and clear.
Okay. Well, thank you very much, Nick, and welcome everybody to today's webinar. We are really excited to be sharing this webinar with you. We are really expecting this new version for a long time. We've been working very hard to release this version 10, and I hope that you will find it as useful and exciting as we have already in the test we have performed so far. So the topics we are going to be focusing today in the introduction of RiverFlow2D and OilFlow2D version 10. I need to say that I have counted more than 500 improvements and new features in this new version with respect to version 9, which was the previous one. That means that we are not going to be able to talk about all of the features that we have introduced, but I have selected a number of what I think are the most relevant features that I want to share with you today. Also, I will like to, at the end, share with you a couple of ideas that we have and also plans that and our ongoing developments that I think you will find interesting as well. Again, if you have any questions, feel free to use your question panel. You should be able to find a question panel in your GoToWebinar interface. And at the end of the presentation, I'll be happy to address those questions. First, I want to start by acknowledging the people that are behind all of this effort. First, the group from the University of Zaragoza, which is led by Pilar Garcia Navarro. We have been having a long and productive relationship with the university group led by Pilar since 2012. So it's 14 years already of ongoing developments, and the tools of the model engine that are accelerated, as you know, with the GPU performance that is so important for this type of applications is in great responsibility of their group. Also, Hydronia Group that is responsible also for the development of the graphical user interface and many of the other features that are not directly related to GUIs, but also to all of the new tools that I'm going to be presenting today as well. I want to also mention that we get sponsorship from the International Development Bank for the specific applications of the model in Latin America, that this allows Latin American countries and also Caribbean countries to access this technology by the sponsorship of the Inter-American Development Bank. Of course, I need to acknowledge also our many users worldwide that also allows to buy their continuous support to make possible these new versions every year that we work hard to make available to all of you. I want also to make a couple of announcements. So we participated this year in the PACE 2026 conference. That's a conference that was held in Lisbon, in Portugal, related to tailings dams. We presented a paper there related to rheology, which I think is very important for this type of applications. You can access the proceedings in the link that I'm showing in the screen. Also, we participated in hydroinformatics that was held this year at the University of Zaragoza, and was a very well attended conference, and I think very successful in terms of the level of the papers that were presented in the conference. Also, I wanted to announce that we are going to be participating in the oil spill conference 2027, the International Oil Spill Conference that will be um, um, held in Savannah, Georgia, in the United States in May 2027. This is a very important conference for oil spills that is being held for more than 40 years, and it's very important for this type of applications. Now, getting more into the focus of today's presentation, I want to give a quick overview of what we have now in terms of the main two models that we develop at Hydronia, which are the RiverFlow2D model and the OilFlow2D model. Now, as for those of you who are not familiar with RiverFlow2D, RiverFlow2D is a two-dimensional hydrodynamic flexible mesh model that has a hydrologic component for rainfall evaporation and has a number of features related to hydraulic structures that it can accommodate, like bridges, culverts, gates, weirs, dam bridges, etc. So this main engine that works both in CPU and GPU environments can be extended by the addition of a number of modules like sediment transport. The sediment transfer module has been evolving in time and is quite comprehensive in terms of the number of features that and the applications that it can have. Suspended sediment bed load, you can have multiple fractions, bed fraction evolution in time, and so forth. Also, the modern tailings module has been very successful in many countries that are dealing with tailings dams and debris flows. In tailings dams, it's been applied in hundreds of projects worldwide. Only in Brazil, there are more than 300 projects where this module has been applied in actual dam risk assessments. The urban drainage module is the one that deals with not only with the surface water flooding, but also with the surface storm drain network and the interaction of these two processes. We have the pollutant transfer module for advection dispersion. and multiple pollutants, and the water quality model that is based on the EPA WAS formulation. That is also one of the pollutant transport modules of the RiverFlow2D. Then we have the OilFlow2D model that has many of the features of the RiverFlow2D in terms of the water hydrodynamics, but also has oil hydrodynamics. The oil hydrodynamics is divided in two parts. One is the overland flow model that also addresses oil weathering like evaporation, oil infiltration, hydraulic structure, heat transfer with the environment, and has also a new module that is the oil pipeline module. Then we have the oil on water, which is a completely different model that handles the spills with particle tracking and has also weathering, shore interaction, containment booms, and spills from moving ships. So all of these form like a system of models that can interact and can address a large number of applications in the area. Now, all of the models are linked by a graphical user interface. The graphical user interface of Hydronia models deals with the input of data into the models that is essential to the model performance, but also deals with the post-processing of our generation of mapping or of maps and animations. So the graphical user interface is based on the QGIS open source system, and it has mesh generation features that allow very flexible mesh to be generated and adapted to any geometry. It has tools for mapping the results in many forms. It has tools for animation of the results. It has tools for profiles and cross sections. And we developed, with the sponsorship of the Inter-American Development Bank, a damage cost assessment plugin that allows calculation of flood damage costs based on a given animation of a model, let's say an inundation in an urban area. It's a very useful tool for cost analysis, cost benefit analysis in flood simulations. So all of these tools are evolving all the time within the Hydronia environment. So we are developing all the times new tools based mainly on input from our users that are demanding new features or improving features. And then we are incorporating as much as we can these new features into our developing process. As I mentioned, there are more than 500 new and improved features in this new version 10. Again, we are only a limited time to address these new features, so I'm just talking about a few of them. And I have divided this in three groups: the ones that deal with the user interface, some other that deals with the RiverFlow2D, and others that deal with OilFlow2D. Some of the main new features of QGIS graphical user interface. Well, there are things here that you will see in the actual applications, and some other things that you will not directly see, but you will benefit from them. So one of the things that you will not see, but you will benefit from them, is the integrated plugins. Now we have all of the plugins for OilFlow2D, RiverFlow2D, and also Hydrobid Flood. They are integrated into a single environment. So from the development point of view, that has a number of advantages for you. And one of them is that it's extends and complements a lot what is the error trapping of the different tasks that are performed. So you will immediately note that there is an improved error trapping and checks that minimize these very uh, strange errors that you may get sometimes, Python errors and things like that. So we are trying to minimize that as much as possible, and this new version goes in that direction. We have also now an integrated data input program in QGIS. So instead of going to an external program, now everything happens within the QGIS environment, and that's also um, minimizes the errors that are uh, uh, generated when you export data from QGIS into the what we call now the DIP, the classic DIP. We have new layers and new options for the layers, and new error trapping for each of the layers as well. In RiverFlow2D, as you will see, we have a new run window GUI. We have also new console output options for accelerated GPU. I will show you this and talk about this in more detail. We have numerous improvements and error fixes in the MT, the ST, the PL, and UD modules, and many other new and improved features. In OilFlow2D, we have also the new run window GUI, the new console output options. We have a new integrated public data download for tidal and wind predictions that I will show you, and I think this is very, very nice feature. And we have general improvements to overland and on water modules as well. Well, on top of that, I think you will appreciate this very much, as I hope uh, you will find uh, very, very useful, is this new documentation portal. This new documentation portal that you can access through this link here, and I will open that for you here. This is a new documentation portal that allows you to access all of the uh, reference manuals for the models. It allows you to access tutorials and many more material that is very useful for the model application. So if you go, for instance, here for RiverFlow2D, you have here the options to um, help for creating a new project, generating meshes, generating animation tools. You have the engine reference. So if you are interested in going directly to modern tailings, for instance, you go directly to modern tailings and you have everything here, equations, links to different references and so forth. So it's very, very useful. You can download this in PDF. It's a complete new portal that I think it will be help very much in the day-to-day use of the model, and you can access, of course, being on the web, you can access from anywhere. In the version 10, also this version 10 has been extended to support the new generation of NVIDIA GeForce RTX cards like the 5090. The previous version were not able to run this version, and this new version has been optimized so that you can run your programs in this version as well. I need to mention that the new version will require that you download and install the most recent NVIDIA CUDA drivers for any of the computers that you have where you use GPU. And this is the link where you can download that those drivers. Now, data input program, as I mentioned, is now integrated into Hydronia QGIS plugins. If you recall the classic, what we call now the classic DIP, it's an external program that you can use to enter all known spatial information. Now, all of this happens within the QGIS environment. So if you have the new version, you will see that you have a new icon at the end of the icons that you traditionally have. And by here, you can access the new dip. It has exactly the same functionality as the classic dip. It's just that it's all integrated, and in future versions, there will be even more integration. So will this facilitates the gap that existed between developing the non-spatial and spatial information within the RiverFlow2D and OilFlow2D models. Um, in terms of the new models, we have overhauled completely the uh, GUIs, that the window, the monitoring window that appears when you run the model. This is one example. All of the modules have now new looks, not only the look, but also the functionality of what you will see. So this is a general view of the case of the hydrodynamic model, so the basic model. You get a information panel here on the right that gives you performance information, some things that the memory you're using for the NVIDIA card that you may have in your computer, simulation setup, so the state, the initial topography of your case, and the actual map of the variables that you are looking at. Of course, the time step used, the Q inflow, outflow, the balance errors, and graphic representing those variables as well. But the most important part and useful, I think, is these buttons here. So while the model is running, you can click on these buttons and look at the map of the specific variable that appears here. For instance, in the hydrodynamic model, you will look at depth as in the same way that traditionally you were able to see. But now you can look also at the velocity and surface water elevation. So you can, for instance, just clicking while the program is running, you can click at the variable and then watch the map as in a dynamic way. In the case of the sediment transport, again, you have the option to look at the depth, velocity, surface water elevation, concentration, or bed changes as well. And you can look at uh, the legend here changing as you change to different variable as well. In the model tailings model, then you have velocity, surface level, flow density in this case, and bed changes. And again, you have also the mass transfer, balance that you get from the simulation. In the pollutant transport, you have also, in this case, depth, velocity, surface water elevation, and concentration. And in the oil oil on land model, then you have depth, velocity, surface elevation of the oil, the flow density, and temperature. So this brings a lot of convenient to the monitoring. So while you are running, you can of course, these are just examples, very quick runs, but when you have a long run, you can look at the details of what's going on, not only at the depth as you were limited in the previous user interfaces. One other new features that we have that it's aimed at accelerating even more the GPU performances is the use of new console outputs. So the reason that this is sometimes necessary or useful is that when you use a graphical user interface in a GPU environment, you have to be aware that everything that you see here, it's calculated or generated in the CPU. So whatever happens here requires a transfer of information and data between the GPU and the CPU. And this tends to slow down the model, especially in long simulations or simulations that require a very frequent output interval. So if you are outputting your results at very short intervals, that creates an overhead that slows down your model. In order to avoid that and accelerate your flow, then we created this option. This option is accessed in the classic dip by selecting the console option here. So you can select the graphic, which is the standard one with graphic output, or the console. In the console, you get just a minimum amount of information while the model is running, just so you have an idea of where it's going, but just a few parameters. And this is all all that you will see. So it's very, excuse me, it's very limited, but this allows the model to run faster. It's not as dramatic accelerations as you will see in the GPU environment, but for sure, for long simulations and simulations that require, especially with large meshes and meshes that are output in very frequent way, you will notice you know, a significant improvement in your simulation times. Another new features of the interface is the new time evolution visualization tools. I like this very much. I think it's one of the nicest features of the new version. But it allows the time evolution of discharge, depth, and other variables at a number of layers: the boundary conditions, bridges, culverts, gates, observation points, sources, storm drain, and weirs. And let me show you. I think it's better to look at that in a live way. So let me bring out this example here. So this is the QGIS interface. I have a very simple, this is the bridge tutorial. So I have a bridge here, and I have an inflow here and an outflow here. So for instance, if you want to look at the boundary conditions, then you right click here, the boundary condition layer, and enter the Hydronia tools. Click on boundary condition graph. Then you click here, and you will see the discharge, both solid, if there is sediment. Of course, in this case, you don't have, this run doesn't have any sediment transport. So you will see only the liquid discharge here. But you have many other features. So you can select here, for instance, a zoom. So you can zoom to specific areas, and as you move the cursor, you see the value in the upper right. You can see the time versus discharge at the different points that you select here. So it's very useful, and again, it's available for not only the boundary conditions. If you go to the bridges here and you click here, then you see, in the case of bridges, you get the discharge and the water elevation in the red in this other column here. So it gives you very quick information on the model results that were not available before. So I think you will find this very useful for many of your applications. I think I will jump to in the observation points. There is a nice feature as well by which you can compare uh, um, the output at the observation points that you have in the model, but also the output, compare the output with measured data. So if you want to calibrate your model and you have measured data at certain observation points, you can import that information in the model and be able to compare the measure versus observations in the same graph. So I think that's very useful as well. There is a new graph that is that shows the velocity vector at one given point, at one observation point. This is useful for especially riverine applications or estuarine applications where the velocity changes in directions and magnitude, and you have a quick look not only at the velocity field but also at the point velocity at a given location, not the magnitude only as it was available before. So these are all useful tools that you can access in the new version for the point data. Oh, this is yeah, this is the example. Sorry, this is the example that I was mentioning about the loading measured data in the observation point panel now. Well, this is the weirs. We have introduced a new triangular irregular network interpolation. This was a long request from some of our users, because in the past the only available interpolation method was only the sampling, which actually is not an interpolation. It's just that at each cell, the value that was used to represent the surface, the bed surface at each bed, at each cell location, was the raster point at the centroid of the cell. So for instance, if you look at a cell like this is maybe the pixel that lies closer to the centroid of the triangle, and the elevations of this pixel was the elevation that was assumed for the whole cell. Now, in the triangular interpolation, we use a different method. We use a bed interpolation. So if you have a triangular irregular network, instead of having a raster, you have as a source of terrain information a triangular irregular network. That means that you have different elevations at the vertices. So this information is used to determine the elevation at each cell of the model. And we have two options here. We have um, uh, integration or interpolation by um, um, inverse distance weighting, and also by linear interpolation. So this improves in some applications also the interpolation that you get to the mesh of the model that you may have. One feature that will also be very useful, I think, for many users is the direct downloading of public data. This is something that we are starting now only for wind and tidal elevations, where we plan on extending that to elevation data and uh, other information that may be public anywhere in the world. And you will be able eventually to download this information and use it in the model. So now it is available for wind and tidal elevations. And I will show you this quick example that I created to show you how it works. This is an example where I use it for wind. So you create in the wind layer. When you create the polygon that represents the wind layer, and you right click and enter data, you can access this tool by downloading prediction. So the the system will find online available wind data for the location you are working on. So based on the search engine, it will find information. In this case, it found information in this NOAA site. And this information is valid for one, you can select the period of time. In this case, it's 24 hours from now. And then it's downloading the information for every hour. So this is a data set, a grid of elevations that it downloads for the polygon. And that information, once it's downloaded, as you can see here, it averaged that information within the polygon that you selected and applies to your run. So this is quite useful, as you may imagine, because it will find information that you can use to run your model, and you don't have to be searching around for the best option. And also one thing that one application where we have implemented this is in the OilFlow2D model for real-time simulations. That is very important in oil spill simulations, because sometimes you are interested in modeling real spills. So you have a real spills and you want to know in real time where it's going. And then you have to use predictions. You don't have the data. So this tool allows you to find the predictions based on numerical models that are available worldwide, and then use that information for your application. Um, Another improvements in the oil pipeline module, we have added a couple of improvements here. One is the valve closing start time and closing duration. We didn't have, in the past, we only had the closing duration, so the start time was always at the time 0. Now we can start the valve closing at different times, and this is more realistic for real-time applications as well. And also we added another option where the system not only uses the points that it selects for you for the risk assessment in the oil pipeline break model, but also uses points that you may have. In this case, you can set your spill location from a point layer. So you select your point layer, and then you can add those points to the ones that the model will select for you based on a given distance. Now, I want to show you an example, a quick example of a real-time response workflow for oil and water oil spills. This is something that it's planned on being used in specific applications for a client in Africa, and we developed that for them, but it's available for anybody wanted to use this tool in the model. So the idea is that you need to use the OilFlow2D. It can be also used in RiverFlow2D because it applies to the wind and tidal components. But the idea is that you can use predictions. So the point here is that you can download the tidal and wind speed forecasts, then calculate the water current velocities based on those forecasts, compute the oil trajectory predictions, and mapping the results. This is something that needs to occur for real spills very quickly. And due to the speed of the OilFlow2D and RiverFlow2D models that perform in GPU, this can be predictions that can occur very quickly and assist you in the emergency planning as well. So the workflow includes the downloading of the updated forecast, as you saw with the wind example that I showed you before. But you can also download tides, water surface elevations at the closest tidal location that you have, or the closest tidal prediction that you may have from global models for tidal predictions. that are available. Um, then once you have that, the model will download the information, process that in the format that the RiverFlow2D and OilFlow2D models require, and then you can perform the simulation with the hydrodynamic model. In the case of the OilFlow2D, you will want first to perform the simulation for water currents. Then you enter the speed location with the uh, volume that has spill at a given location. Then you perform the oil and water uh, drift or spreading simulation. And then you can generate decision support maps in a number of ways. Um, so the real-time response, once you have that information done, it has a number of steps. Um, Again, this is what I illustrated previously, the wind layer downloading information that you get from public data, and also the tidal information that you can also get from public forecasts. Then you need to recompute the water current fields using the standard tools that we have. As you can see here, in this image here, that we are using the new version with the new OilFlow2D graphical user interface. Then we set the speed location, whatever point it is, and then you perform the trajectory simulations and the maps. Going fast because I need to still catch up with a number of things that I wanted to show you at the end. But so at the end, you get trajectory plots. These are simple trajectory um, um, animations that the model can create, as you can see here. Um, but the, the idea is that with these tools, you get very quick model outputs that can assist in providing very valuable information of the oil location and oil trajectory that can happen in real time, which is essential for this type of emergency planning. One thing that another feature uh, that the model has now is that uh, instead of starting the model from a point source, you can start from an observed slick extent. So in real-time applications of real spills, you get sometimes the information of where the oil is located from a satellite image. So let's say the oil, instead of being in a point, is distributed in a given area. So in the new version, you can enter a polygon where the oil resides at time 0, and then you can perform the simulation of where the oil is going to go um, from that initial satellite area that you have entered. And in the classic um, data input program, you set that information here, use the initial oil area. These are some detail, but I just wanted to show you the an animation of a simulation. This is in Bahia Blanca in Argentina. We performed this for a client. This is the initial location of the oil, as you can see here. And then as the time passes, you see the trajectory of the oil and where it is located from that initial condition generated by a satellite image. Um, well, all of these features that I have presented and many others that are included in the version 10 will be available from September 1st from a website. So we'll be including a trial version and a full version for all of our current maintenance users that will be able to access all of the features of the new version directly. And if you want to test them, of course, you can download a trial from our website from September 1st. I'm sorry, 20. This is a mistake. Obviously, we don't. We sorry about that. Uh, I'm just a little ahead of time here. So let me correct that just so for because uh, this video will go to YouTube as soon as it's done. So I need to correct that very quickly because otherwise people will say, well, these guys spent 3 years just to uh, release the new version. So again, so September 1st, 2026, so that means next week, you will get that from our website, okay? Okay, so I don't know if you recall this guy. Those of you who have been in the planet for some time, you may recall. Otherwise, this was a show, a TV show called Colombo. I was a detective, and in all of his um, shows, he would at some point say, ask normally to the criminal guy or someone. Uh, but there is one more thing, and this was taken also by the great uh, uh, director of Apple computer, and he was famous for that phrase as well. One more thing. Okay, so what is this one more thing? So I want to share with you this uh, ongoing development that we are doing as we speak. We have, I want to share with you the ongoing development, what we have, and the plans that we have for the next few years. And this is the artificial intelligence assistant for Hydronia models. We've been thinking about this for a long time. And, there is everybody's talking about artificial intelligence, AI here, AI there, the pros and cons, what we do. Everybody needs to get into this train because otherwise you get behind. And it's true. It's here for good. Uh, but we wanted to do it in the right way, at least what we think is the right way. So from Hydronia perspective, our purpose is to the purpose of integrating AI tools into our models should not be to accomplish the same thing we have done so far with less people or no people at all. So that's one approach. We don't want to follow that approach. That means, okay, we're going to do modeling, autonomous models, and we don't need people anymore. Just the model, the AI would do, agent will control everything and do everything. That's not the idea. We don't have that aim now. Our aim is to help you accomplish more things, more work with a higher quality results and complete your work in less time. So that's our main goal with the integration of AI tools. Of course, this will require less effort. If you want to do less thing in less time as well, that's up to you. But we want to give you the tools that will allow you to do more in a better way and in less time. That's our main objective here. So this is the thing. The challenge with the hydraulic modeling and environmental modeling um, is that we have these powerful tools, but they can be very complex. They can create problems not only for new users, for even for experienced users. And I know today here we have many experienced users, and you know what I'm talking about. So our goal is to address these issues in with the incorporation of AI tools. Um, so we have complex workflows now with multiple independent steps. We need to address DMs, mesh generation, boundary conditions, manning setup, exporting, simulating, visualizing, interacting workflows. Um, the search for the information that you need is sometimes difficult to access. With, of course, with the new portal, that will be greatly simplified, but still that requires some time to get familiar with. And then, of course, you need some time to learn the tools. Um, there are new features like the ones we have been talking today uh, that generates new challenges to even for experienced users. So what is our plan? Now we are working in the first uh, frame here. So we are developing now a local assistant with guided workflow that is integrated in the models, in all the models, not only hydrobid flood, but all of the models. Um, this is a local, the idea is to have a local engine with no subscription necessary. So this will something that will not necessarily require that you have a chat GPT or a Claude or Gemini or whatever other subscription. It will run in a local AI engine and will be manual based assistance. So based on the information that is contained in all of the manuals that we have for the model. So that is on its own will be a great help because it will guide you with simple questions and answers that you may ask to the assistants through the process of implementing a model or even debugging a model. Then we have a medium term goal from 2026, 2027, where the models uh, will uh, train with proprietary data. So as the model runs, it learns and it will enrich the knowledge of the system with frequently asked questions database, specialized training for modeling, improvements based on user feedback and connection to support forums. So this is a secondary step or stage that will be in the next couple of years. Then we have a longer term objectives with much more ambitious goals with advanced managers for experts, automation for complete workflows, with not necessarily interaction or minimal interaction with the operator, cloud options for advanced features. That means that could require subscription in this stage, analysis and calibration tools, and autonomous question and answer assistant. So this is our plan. We have started already, and we have very encouraging results for the first stage. So the uh, the idea of this first stage is to have the AI assistant integrated into QGIS. So it's difficult to see here, but this is one of the test cases that we have in this initial implementation. So the user will have simple answers here, questions and answers that it can be. This is, by the way, in Spanish because this is the first version that we have. If you are starting from scratch or you have already one project or you want to visualize results or you want to ask questions about the model, then you have predetermined questions that you can enter here, and then you will be guided to answer those questions. So in this way, you will be able to access the system, the assistant, the agent will search the information in the database that is available locally, not with any require subscription, and it will help you in the process of implementing or analyzing your project results. So this we plan on releasing this in English, Portuguese, and Spanish, which are our main languages based on the users we have in these countries that speak these languages. So they will facilitate also the communication with the users in the countries speaking those languages. So the main aspects of the assistant is the guided workflow, questions and answers, and manual search. Manual meaning the reference manuals information. So there will be deterministic navigation, the steps necessary to start simulation, checks that are necessary to make to avoid errors, um, conceptual options that are available in the model, selections of coordinate system, um, information related to the dialogues of the model, and in general, this does not require any AI directly for the navigations. However, with the local AI model, again, this is something that will run locally without the subscription. You will be able to add free form questions or add your own questions to, what should I, how can I improve the mesh or things like that, open questions. In this case, the AI model will run locally and provide the information to your questions, to respond to your question. Then we have the manual search, which is a local knowledge base based on AI assistance. We look with the help of the agent into the local manuals also in your computer. So, well, these are some details of the application, the tests we have run so far that, again, I think they're very, you will find when this is available, which is not yet, but when this is available, you will find really very useful, because it allows you to be, especially for people that are not so familiar with the model, it will guide you through the process of implementation. So, well, that's what I had for today, and I want to take maybe a couple of minutes. I have taken almost 1 hour, and I apologize for the delay, but it's a long presentation, and I'm very short on the number of features of the new version that I wanted to show you, and the plans, of course, that we have. So if you have any questions, let me see if I'm able to access. Okay, okay, I'm accessing here let me see, the question panel. Okay, I have a question here. Can RiverFlow2D simulate filtered tailings runout? What formulation is recommended, and can determine the mobilized mass failure extent, or does that need to be provided externally? Yeah, RiverFlow2D, the mod and tailings module, can simulate the runout distance from tailings of any type. You can um, represent um, the properties of the tailings. It can be uh, dry, granular tailings, or you can have very dilute or wet tailings as well. And the model determines how that mass of tailings is mobilized, and how it flows over complex terrain, and how it also interacts with the existing terrain as it moves and eventually stops if that happens. So that's one of the capabilities of the RiverFlow2D mod and tailings module. that you may want to use for that application. I have here another question. Does Hydronia support NVIDIA RTX ADA generation GPU such as RTX 6080? I think so. I don't have Nick, do you have information? I suppose that this would work, but I don't know if we have run a test on that particular card.
Hi. Yeah, so we have tested on the 5090, which I believe is the same generation, if I'm not mistaken, and that was successful. That was actually we had to work on that because at first it did not work. There was big changes into that new architecture. So we do have testing on the 5090. We don't have testing on the 6000, but we plan on running tests on that GPU as soon as we're able to get one available. They're very difficult to test on because of the shortage of GPUs and everything that's going on with AI right now.
Okay. Well, I don't see do you see the question panel?
I see one more question.
Okay, let me see. Okay, there's someone focused on oil prevention and containment. Well, yeah, for oil prevention and the question is how can the software address oil prevention, oil spill prevention and containment? Well, the main purpose of the OilFlow2D, or one of the purposes of the OilFlow2D model, is to address oil spill risks from pipelines, storage tanks, or marine spills or riverine spills. So the typical applications of this model is to first prepare, for instance, emergency planning. It can be done for prevention as well, because you can assess the probability of an oil reaching a water body, and then what measures you should take to avoid that oil from getting to different water bodies, that type of thing. So that's the main, probably one of the main purposes of the application of an oil flow 2D model. Yeah. If you want more details, feel free to reach out to our email, and we can have a more specific demonstration about the application of the model, how it works, and what are the main characteristics of OilFlow2D. Okay, so I think I have completed the even more of the time that I had originally estimated. But thank you very much for your patience and dedication to bear with me. And I hope you have found this information useful. If you have any comments or you want any more detail about the new version that is coming out again September 1st, next week, feel free to reach out to my email and our website as well. And again, thank you very much for your time and interest. And I hope to see you soon in a forthcoming webinar. Thank you very much.